that has to be a certain distance above the PCB and the transmission lines. First, let's take a look at this board actually uses an RF shield, as many do, over the RF section, and that often helps with FCC compliance and other things you have to do. But the shield is going to affect your impedances and your transmission line characteristics for the microstrips underneath it. So the general rule is you make it greater than, and I said 2B here, but that's actually incorrect. I already uploaded the slide and too late to change it now. But we want the height of the metal shield above the surface to be really 5 times the thickness of the dielectric under microstrips to the plane, to the reference plane. And that's usually pretty easy to achieve, but that way its effect, you still want to measure it and you probably will still make some adjustments, but its effect is greatly reduced as long as you're above that height. And of course, all of this comes into things like FCC compliance and testing and getting certification of your product, which is a very expensive thing to do. Wherever possible, of course, it's a good idea to use off-the-shelf modules and not have to do much RF if you can avoid it, unless your product really needs it, and that's why you're here. So next, let's take a look. If we look at this Lime SDR board as an example and remove all the parts and the RF shield, we'll take a look at how things have been laid out by the gurus who did this design. First of all, in our top layer, you can see it is a microstrip based structure. And in fact, if you look closely there, you'll see differential pairs as well. So we actually have, for the RF analog front end of this design, differential pairs, coupled microstrip lines, and there are some actual RF transformers, wideband magnetic transformers used for coupling before heading out to the SMA connectors. You can see the material, the dielectric there, is going to be on the surface layer, a dielectric especially good for RF and high frequencies, something like a Rogers, something probably not PTFE necessarily, but something more ceramic based might be the go. These can push up the cost of your boards, but bear in mind you only need those dielectrics on the outer layers of your stack up. You don't need them in the core where